So welcome everybody. Welcome to CDS for Crimson for the EU release, umbrella release. We're going to go over briefly trackers targeting V21 in our tracker with features, known bugs, enhancements, and so forth. Later on, the Etherpad mentions some topics we're going to go through, and finally questions, and that is going to be it. So I'll begin. Feel free to stop me, ask questions for having a discussion. So the presentation was just for making it easier to see what we talk about in the tracker. So I'll start. First thing, we have targeting the release. The effort already started in the Tentacle release, but we've decided to separate it into few sections. This feature is about PG splitting and merging, about enabling the autoscaler in Crimson. So this is being currently worked at by Aishwarya from our team. So the initial PG splitting work has already been merged. This is the pull request there. If anyone is curious, by the way, with links and all that, so the tracker in the Etherpad should mention all the links here. So as I mentioned, the first initial work has already been merged in main, which is going to be you eventually. After that, we decided, before moving on to merging, to start to stabilize splitting, as we did in classical OSD back in the day when we initially introduced splitting and merging. So a first batch of fixes was already merged. It was 1 week ago. And we started to enable some thrash and heavy workload with ongoing writes by multiple clients with splits, with PG splitting on the background. And the run attached there has started to see some green jobs. So we are on the right path to it. The next step for that is going to be, once we are certain enough to move to PG merging. Aishwarya is not here today, so if anyone has any comments, questions about that, again, feel free to stop me. If not, I'll continue to the next one. We have a few of these. Next one, this is a quick one, more of an infra related. We decided to separate Crimson builds to debug build type and a release build type. And our nightly's QA runs is running with both flavors. Some bugs are only seen with one of the other build types. For now, PR gating is only using the debug one because we want built-in asserts in. But we do expect users to deploy eventually with release builds. So we decided to also make sure that everything is stable there. And we already had a few rounds of fixing issues that we are quite more reproducible with release builds. So for anyone interacting with Crimson in terms of images, QA, builds, all that, so there is a required flavor that needs to be passed, either Crimson debug or Crimson release. This is already in main. And yeah. Later on, this is one really important enhancement we are targeting for you, and this is also actively being worked on by Mohit. This is about SeaStore being able to deploy Crimson clusters with SeaStore as a backend. In Tentacle release, we have only were able to do this with BlueStore as a backend. In the EU, we're planning to actually support also SeaStore. Some of the parts are already merged, such as Ceph volume support to deploy with SeaStore. This is already merged by the Ceph volume team. We had some missing pieces around SeaStore that needed to be merged as block signatures to be able to know which store is actually being deployed. And the next step is going to be actually enable integration test in tautology with Ceph ADM deployments before we can actually suggest user to try it out. And it was actually today, I did it just earlier today. We had the first successful job with Ceph ADM deployment with SeaStore. So that's cool and a good timing to do that. Later on, this is also being worked by Mohi. This is about QoS, mclock support. So the PR is already there, not merged, still work in progress and waiting for, this is work in progress. We had some dependencies that needed to be resolved first in our common mclock implementation and the mclock submodel, which is already not a submodel, but part of the Ceph repository, about the way the background garbage collector thread is working in the DM clock, which needed to be adapted to the way Crimson architecture is working. This is a PR by Sam Just, which is quite ready and I think is close to being merged, and the mclock support PR could be tested and merged also. Another thing we saw quite recently is that our docs documentation, official documentation, was a bit targeting also users and developers, and it could become quite confusing to new users or someone who is new to the project and trying to deploy for the first time. So we've decided to introduce a separate user guide that won't include all the non-necessary things that are not related to users, such as debugging the internals of SeaStars or vstart cluster and so forth, but will only include how to pull a Crimson image from Quay upstream and how to test it, which flags needed to be used for your first deployment. And the first PR, which is mentioned here, is already merged. This is not in the separated documentation. The separate documentation is one of the goals for you to have a proper one that is ready to be read by anyone. Another target, now we feel that our OSD layer is becoming much more stable than we had a few releases ago. And also SeaStore is starting to prove that it's being to be stable against complex workload. And we can now actually start to publish some comparisons. Of course, this is going to be changed quite frequently as main changes and some fixes that are pushed or may really impact this result. But for you, we decided we should start with publishing some numbers that we could compare for mini releases or for from time to time. And again, for folks to just read and understand where we stand, the potential, and so forth. Jose from the UK is doing a really good work so far with analyzing Crimson's performance in the Crimson Slack channel. No official reports were still published, no numbers. Of course, as I mentioned, this is changing quite rapidly, but we should probably start publishing more official numbers. There is a tracker for that, and currently the idea is to simply compare the most simple cluster we can to see just the raw IOPS, latency, and so forth. Jose, if you're here, if you'd like to add something or any initial ideas, I know you started to look on that. I don't know if you're here. I can't really see.
Hi, Matan. Yes, in fact, I wrote a couple of slides, if I may share the screen or...
Yeah, of course. I'll turn off my...
Hopefully you can see the...
Yes.
Okay. So basically, in this two slides, I have previous results that Matan mentioned that we published in the Slack channel. Sorry, this should be later. This is what I meant. This is just a quick comparison between Classic and SeaStore. And this is using modality in FIO for the latency target. So it's a relatively quicker test run as opposed to response curves that I show in the next slide. But the basic idea is, as Maten said, with a single OSD cluster configuration and using the appropriate reactors for Crimson, we have these figures in which Crimson SeaStore is clearly ahead for random read 4K block sizes, but still needs to catch up, so to speak, for random writes. This is a run that I did the same month on May 29th on a different build. And in this case, we are exercising, it was pretty much an experiment in which without making things very complicated, for the machine that we're using is an Intel architecture, and it differentiates the types of CPU cores between a physical core and its hyper-threaded sibling. So in this case, we ran tests for lack of a better name. I use the term single to refer to the configuration in which we have 20 reactors, and dual for 56 reactors. Actually, I tried a better name, but the idea was to explore some pinning policies for the reactors that are now live in as part of the changes that Sam just did for a PR in which the Python code does the work for assigning or pinning the reactors to CPU cores in an appropriate way using two policies, the based OSD balanced or NUMA balanced, and this illustrates precisely the OSD balanced. So, and yes, so as kind of a proposed configuration for this tracker that I already updated, it was besides these simple configurations, if time allows, to use a configuration in which we divide the number of available CPU cores among the OSDs, assuming that we have a mapping one-to-one of OSD processes with the available NVMe drives, in this case for the machine. So I made the example here in which we could use 6 reactors per OSD for this configuration. Again, exploring in terms of scalability, whether if we have half the number of OSDs and drives, we could potentially use the double number of reactors. On a previous report in the Slack channel, we have precisely measured the scalability between the number of reactors increasing per OSD. So yeah, that's the proposal pretty much. Be happy to answer any questions you might have.
Thanks, Jose. And also thank you for sharing the numbers. For the initial proposal, it does sound and looks good to me. Of course, we can start with a more simple and straightforward deployments, as we would expect first-time deployments to be, with using our automatic CPU pinning configuration, and from there we could move to actually pinning each one to the relevant host, as you mentioned, and so forth. And probably also worth mentioning that the numbers shown there, you did mention that there were a few fixes merged, but we expect those to change since there were quite a few fixes since it was 3 or 4 months ago. And yeah, so if anyone has anything else to add, if not, we can move on.
Thank you, Matan.
Okay, so moving on. I'll continue to share my screen. Okay, so the next tracker and feature is the erasure coded pools. For now, Crimson only supports replicated ones. This is work in progress by Radoslav. we decided to separate this work actually into two pieces, because we had also a lot of EC changes happening for before before the Tentacle release, and we wanted for Crimson to try at least to have already the fast EC changes within in its first EC support. So one PR, which is named the Shuffle Fast EC code, is ready, I think, to merge, and this is currently targeting main, which pulls out the common parts that needed both by Crimson FastEC and Classic FastEC to not needed to keep rebasing or re-implementing the same common code twice. The main PR, which is listed there, is rebased on top of that. And yeah, and Radek, if you're here, so if you'd like to provide a quick update as to the current effort and what's targeted for you, it would be great.
Hello. I think that okay. One, as you said, it's ready to be merged, and moreover, it's also ready to be backported to Tentacle. Uh, that's the main idea behind the hub of changes related to the share of classical code and this would be uh, this keeps the door open to have the main ESPR separate in plasticity. Also backported. But yeah, I think it's the main we make build in main and then in umbrella with the doors open for backported. Right
Cool.
now, I think I'm working on consuming the second fix pack of FastEC changes in main. Uh, I'm doing for a nasty pack, which looks also to be in the main in the classical code. Work in progress.
Sounds good. Thank you, Radek, for updating and for working on this one. If no one has any question, we could move on. There won't be a lot of slides left, so okay. So as MISC with a few enhancement features and trackers, some of them are not yet assigned, but they are targeted, and we expect to at least try start working on them to be targeted for umbrella release. First one is RGW support. The support should basically be almost ready. This is currently unassigned because the Rados API is stable. We test it quite frequently, so we expect the RGW to also be supported quite naturally. But we would like before to start enabling some tests and add them to our suite before we can be sure about the RGW support. Second thing here on the list is the mixed, which is Crimson and classical OSDs. This is, we expect one day, of course, not in the due release, to support migrations from Blue Store and classical OSDs to Crimson and SeaStore. This is the goal eventually, and this is most likely the best way we could now see to implement this would be through backfilling, and for this we would need to be able to support a mixed cluster. So this tracker is tracking this effort about seeing if we have any missed bits that would not be supported and needs to be solved or implemented before we could move on to implementing migration and supporting migration paths. Third thing in the list is supporting a scrub. We do have scrub. It's currently on demand. We have a deep scrub and shallow scrub implemented. We use this for testing to make sure everything aligns, and it helped us to catch quite a few bugs already. But the next step would be to implement scheduling and preemption and repair and all the full scrub support as the classic OSD has and as expected from full Ceph cluster. The next two are already merged in main. First one is the Crimson pool mode. Pool mode is that with the SeaStore reactor currently, what it really does is enables 100% CPU utilization. Just lets the SeaStore reactor keep polling for tasks. We don't expect real cluster to really use this, but it could be really useful for some performance evaluation and to be able to spot some bottlenecks for folks interacting with Crimson OSDs. So, and from there, we could move on to adjust some of the reactors parameters that are already exposed, the SeaStore reactor parameters that are already exposed in the Crimson options. Last one is the store bench tool. This was originally implemented by Shuraya and Sam. This is a really handy tool that allows us to interact directly with the Futurate store. This works with BlueStore and SeaStore, and it offers some common workloads that could be tested and see how the store really reacts and measure the performance and behavior. For now, we have 3 main workloads there, which is bglog, RGW indexing with OMAPs and random writes. Again, this is mostly for development and being able to directly interact with the store without needing to set up a cluster with OSDs and so forth. We expect this tool to be expanded the more we see more workloads are needed or missing. This is the last slide, I think. I try to summarize some of the SeaStore effort, the backend, the object store for Crimson. It's really hard to put in a few slides, and I don't want to take all of everybody's time. I mentioned here a few of the efforts. Some of them are already were merged, and some are still work in progress. SeaStore is going to be one of the main goals in U release. As I mentioned earlier, it's already been much more stable, and we want it to be the default object store and used for testing with Ceph ADM, as mentioned earlier, and users to interact directly with it because it supports the Crimson. It's built with the Crimson native architecture. So this is really we really expect. This is the last point here, but I'll start from the beginning. Some of the main points is the being able to support shard number changes. This is work being done by Chunmei. We currently had the SeaStore being able to set the number of shards only upon MKFS. We decided to allow this to be more dynamically changed and currently blocked by an option. Still work in progress. Another missing bit work by Shuhan is the clone range 2, which is, I think, quite close to being merged, and it's a really important missing object store operation that SeaStore currently lacks. This will also help us enable recovery thresh test, which is currently disabled in the suite with SeaStore. I think that I'll skip a few here unless anyone has any questions. But of course, this is in the pad, and each one has a separate trackers that anyone can see or take a look. The last point here is also mentioning beside the main effort, part of the main effort would be emphasize on code readability. Large sections of the OSD code, of the Crimson OSD code, were already switched to coroutines, which are supported by the SeaStore and makes the code much easier to maintain, to read, and to allows us to avoid many bugs and makes code reading, writing much faster. So the SeaStore code still hasn't been switched or used coroutines so far. So we already have few PRs in main. I think some of them are already merged and some are awaiting review, which are as part of this effort. And of course, besides stabilization, performance bottlenecks. And I think I saw a few topics around this subject, so we could continue talking about this in the topics section. And I guess that's it. This is we're not finishing the call, but just a good reminder that we have a Slack channel, a weekly meeting, a tracker, and of course a backlog in GitHub in the main project page in Ceph.io for anyone who wants to take a look. I'll stop my screen sharing now, and we could move to the Etherpad to go over the topics and questions we had. And of course, if anyone had any questions. Sam, would you like to take it away?
Sure. If you look at the pad, you can see what I was, my topic. I'm looking at a SeaStore small random write performance. The goals for you are just random write performance to bring it up to par or beyond SeaStore, or at least just fix a significant number of the bottlenecks we have at the moment. And then we will want to update the defaults to reflect any changes we make so that it behaves well without a lot of effort on user's part and better documentation. So the current investigation is into are avoiding a read modify write on partial writes for unloaded extents. Right now, if you do a 4K update on a 16K, that's going to read the whole 16K extent only the update. We'd really like to avoid doing the read at all. If it's blind. Second bit is better journal batching to require larger writes with more outstanding IOs. I have a prototype for that didn't make much of a difference yet, but I suspect it will later once I fix other bottlenecks. I'm also adding a lot of metrics to make it easier to tell what it's doing. So I'll be working on more concurrency for background operations. We have parallelism in that we have one of these background operations running per shard, but likely it'll be better to submit more transactions concurrently per shard. We'll see if that turns out to be necessary though. That's it.
Thanks, Sam. No one has any notes. We could move to the last phase, which is the questions. Jose, I saw you have some questions. Would you like to start?
Hi. Yes, thank you. More of a curiosity, really. The motivation is that when getting flame graphs from Crimson runs, I get very tall towers, so to speak. So that makes quite a bit of a challenge to analyze. I have partial success for particular components like the benchmark that is a synthetic benchmark for the messenger, that I managed to implement some replacement some forms of compaction so that could be more chattable and easier to kind of follow the what parts of the code are taking such amount of time. So I was wondering about some kind of a generic, for lack of a better name, code landmarks for each of the main components that I am describing them in the question: the messenger, the placement group management, and the object store, so that I could apply some kind of insight into the frame graphs data that could be useful to compact them into these landmarks identifying. I mean, I think it might not, it could be very difficult because I understand that the code is executed asynchronously. So once a feature or transaction is being delayed or being resolved for the eventual the lambda function, and the reactor might be doing something else during that kind of a lapsing of the asynchronous processing. But I was still wondering if something along those lines could be possible. And the main end is to kind of attribute for each of these components what is their contribution to the overall I/O latency. Again, this could be a bit tricky because what we have normally in the measurements are counters, and was wondering when this, assuming that it's possible to have these landmarks in place, and it could be possible to extract information from the frame graphs of what is the CPU utilization for those, we might do some estimation in terms of latency or their contribution to latency. So that was the
So
first.
flame graphs are tricky. The way they actually work, the way the tool actually works, is it unwinds the stack and records the stack frames, right? So there is no analogous stack in SeaStore. When it performs an unwind, it's going to work until it hits the reactor itself, and that won't necessarily be the place where the I/O started, because as you observed, if a future is delayed, then the callback will be at the top of the call chain, not the originator. So flame graph tools, generally speaking, aren't going to work in Crimson. I don't think there's a way to adapt them to work. The only thing you can get out of perf would be per function attribution, but the call chain part is just not going to be applicable. If you want to measure latency, we can do that with counters. CPU usage will be more challenging to attribute. I don't have a good answer to that one.
I see. Thank you, Sam. I understand. But that will mean that in principle we might need to instrument the code rather than use flame graphs.
Correct. We will definitely need to add latency counters that are documented and easy to find, so you can break down the overall I/O into a set of nested latency counters.
You know, there might be a way to get maybe not so nice flame graphs as with perf, but at least some PMU based insights into what's getting crunched by CPU. I recall that I think Jaya, generally speaking, Blusterfox, were experimenting with basically a scope, C++ scope based retrieval of a counter from PMU. If that's the case, perhaps we could reuse it in Crimson. And as many of basically everything is wrapped with interruptible futures or iterator, perhaps we could integrate that machinery there. We already do the checking of interrupt condition in many places. Perhaps this performance gathering isn't so far away from it.
I mean, that sounds pretty speculative. That kind of thing is a lot easier to do with synchronous threads, because you know that nothing else will execute on that thread between creating and destroying that context. With coroutines or asynchronous stuff in general, that's not really true. The CPU might open and then leave open any number of these contexts at once. And I don't know how many of these contexts the PMU hardware can deal with.
That's the reason for scope based. In my understanding, coroutines are still atomic in terms of single, let's say, lambda. In terms of
They don't preempt. That's true. So if you're just trying to measure, or if you just want to attribute, so one thing you can do is in SeaStore you can mark, I forget what they're called, different execution contexts, but there is, so far as I can tell, no way to attribute the reactor to CPU usage to those contexts. Like ideally, we'd be able to say, okay, this task is associated with the OSD, this task is associated with SeaStore, this task is associated with the messenger. And then the reactor.cc could tally up the CPU time attributed to each of those things. That would be a good feature for SeaStore, but it doesn't exist right now. And yes, that is something we could possibly use the PMU to track. Again, it's fairly speculative. We'll want to consider a few different designs.
I agree. At the
But
moment, it's pure
like metrics that we can already collect, that we can just do right now. That's easy. Sorry, that was all I had. Go ahead, Reddick.
I'm done.
I guess one more thing to add, Jose, to your question, how to measure each one of the components. So without a dedicated tooling such as flame graph, which might not fit but could be potentially adapted to. For example, the messenger has its own engine, introduced some of the, like we saw a few months ago, ping pong test that only test the messenger layer, and we can spot some latencies there and to analyze that. And as far as the object store layer, so we have the bench tool, which I mentioned earlier, that can be tested to directly measure object store latencies and IOPS, and without the OSD layer. And for the OSD itself, we could use, of course, the OSD with the in-memory SeaStore or the memstore we have in Classic that does not really write to disk to better analyze each one of the layers. But as far as tooling goes, as Radek and Sam said, it might take some time to more properly make them work and fit to our goal here.
Makes sense. Thank you. Thank you all. The last question I had in the path was, again, curiosity, wondering about one of the metrics that we have for SeaStar, in particular for the reactor.cc module, that is called the memory cross CPU free operations. And I was wondering how local the memory utilization from the point of view of the reactor happens in terms of allocation of the allocation. I'm starting to kind of collect these particular metrics for the reactors and kind of try to figure out whether how local is the memory usage in particular. Wondering if there will be some potential polluting of cache lines that for many small operations that could be a hindrance. Any suggestions on that?
Yeah, the main source of there are a few places we do expect to see cross CPU allocations. Messages coming into the messenger are not on average processed on the same reactor. They'll tend to need to be passed off to the reactor with the PG. So the allocation of one of those messages and the freeing of that message are likely to be on different reactors. The other cases, logging and a few other bits of sort of process-wide bookkeeping, we expect cross allocations for those two. Everything else we expect to be local. So it would be interesting to confirm that that's really true, which I think you would be able to do by comparing the total set of CPU allocation free cycles to this cross CPU free operations counter. Well, I would expect the percentage to be pretty low.
Makes sense. Thank you, Sam.
So I guess that sums it up for the questions and topics and everything we had so far. So if anyone has anything to add before we end, so this is the last chance. If not, I think we can close this one for today. So thank you all for joining and have a nice day.